Hey everybody, this is Bmaldonato here. Um, Today I'm going to be talking about installing a fire alarm system. So, say you want to install a system on a building with multiple floors to it, like say at a college. You're going to have to run that in pipe with compression fittings and whatnot. You're going to have to run a pipe. You're gonna have to have a panel in on every floor, and usually they try to have a chase in the center of the building that goes like from the bottom all the way up to the top through the middle, and you would install your fire alarm panels on every floor all the way down. Um, you're gonna want two pipes going from every panel. You're gonna want one pipe going down straight from that panel down into the one below it. Then you're going to want another pipe that goes up out of that panel, 90s over, 90s down, goes to the next floor with 6 feet of separation between that pipe. And it's going to loop back to the panel that you just ran, or that's on the floor below it. And then you're going to run another pipe down from that panel to the next panel. And then you're going to run another pipe up into the bottom of it. See what I'm saying? So you're going to have two pipes in the bottom of the panel. And you're going to have, or however you decide to run it. You could even, come up out of it, come over, come down, come over and come in, but then you need a pull box, and because you're dealing with multiple 90s, and you can't go over 90, you can't go over 360 degrees before you have a pull box. So I mean, you want to mount a pull box, go ahead, do it that way. You can go over the top and down into the panel. It's actually a preferred way to do it because it keeps the pipes overhead, and it's nice that way. But yeah, you want to actually make a loop of pipe with 6 feet of separation between the pipes, and you want that loop to go around from panel to panel to panel, like all the way from top to bottom, and it's just gonna loop and loop and loop and loop and loop. Every floor is gonna have smoke detectors, maybe heat detectors, um, maybe some floors will have in mechanical rooms where you're gonna have to install duct detectors. Um, there's a fire sprinkler system. It's got a tamp and flow, and both the tamp and the flow have to be connected to. Um, and it's an in and an out, in and an out, in and an out. It's all in a loop, so you can't like T-tap off of a device just to hit a device and keep going on. No, you have to run a wire to the device and then out of that device, and to the next device and out of that device, and to the next device and out of that device. And it runs on DC power. It has like a constant 19 volts going through it, but these devices pulsate, or they do different things to tell the system what it's actually going on, what's happening, stuff like that. So, anyways, when you run your wires, you just go into the device, out of the device, into the device, out of the device, into the device, out of the device, and you with your horns, it's probably a good idea to run a clover leaf, but if you do, to keep from having too many pipes in your panel, bring it around one side of the floor and back and run it into your panel with one pipe. Then bring it around the other side of the floor and bring it around with a pipe. So you're going to have 4 pipes total, basically. Um, but uh, those runs, they're going to be it's going to be a clover leaf around this side and a clover leaf around this side. They're going to meet up and join together in a junction box, and then they're going to go down into the panel. That's your horn circuit. Your horn circuits, you know, it's a little bit more, it's a little bit simpler maybe. But if you do it that way, if you ever had a short in your horn circuit, like a wire touching the ground, you could go in there and you could measure for it in each of the circuits that it's landed to, and you're not going to know what device it is, but what you can do is you can set off the zone with those horns, and it'll actually show you what zone to look in, and then you just check all the horns in that zone. So you only have to look in the quarter of the building instead of having to check like a whole half of the building, you know what I mean? Or maybe even the whole building. If you were to go around the whole building and just land 2 pipes in the panel with your horns, oh man, you're not going to be able to identify where that short is. So if you do a clover leaf and you go through there on both sides, you go into there with the one pipe, and then you clover leaf again over here with this pipe, and you join them together and you bring it all down, so it's all going this way and then this way and then this way and then this way and down into the panel. And that way you can actually set off the zone that short is in, and you can find out where in that building your short's at, and without checking every device on that floor. It's actually a pretty smart way to do it. But your duct detectors, when you install those things in like in high volume air conditioning, like really high volume air conditioning, like cooling a skyscraper, a 6-story building, you know, something like that. You know, there's the big mechanical rooms. They have big motors. They have big duct work, and uh, in that duct work, we have to install duct detectors that will actually sense smoke going through them, and they have to be installed in the direction of the airflow. So there's a channel inside the duct detector, and its inlet needs to be before the outlet in the inside the ductwork. So the part that your sampling tube connects to, that's the inlet, and you want that facing the airflow, like facing the direction. So you want the air to go in those holes in the sampling tube and through the little channel in the duct detector and then out, so that the duct detector has a way to sample the air that's going through there. And apparently these new ones that they're putting in can actually tell the difference between dust and smoke, and they can actually tell you when it's time to go in there and clean your ductwork, which is actually pretty cool. Um, but you know, you hook all these devices up, you know, by their directions. The horns are easy, you know. Red goes to red, black goes to black. It's in and out. That's a simple thing. Um, and your smoke detectors, your heat detectors, you hook those to like 2 and 7 and something else. I think maybe 1. I don't know. It's in the directions. Read the directions. Read all the directions. Those duct detectors, you have to hook those up correctly too. That's in the directions. So you need to read the directions of how to hook up one of those things. And after you read the directions, then you don't need them anymore. But don't just throw them things away right away and think you know how to hook it up, because you don't. So just hook this stuff up, in and out, in and out, in and out, in and out, and you won't have a problem. You just land all that stuff into the panel, and you connect it to its respective locations, and program all the devices, because every device has a barcode on it, and that barcode corresponds to the device. And so the barcode gets scanned into the computer system of the fire alarm control panel, and all of the device IDs are identified in their locations and everything, so that if the fire alarm system goes off, the fire department knows exactly where to go in case there's a fire. They don't have to go searching for broken glass tubes on the ground or anything like that. They just follow the smoke. No, they know exactly where the fire is, and they can just go straight to it. And that's actually pretty cool, because it actually connects to the phone system or the data system, and it notifies the police if there's a fire that happens. So, yeah, these systems are pretty cool. I mean, you just connect everything in a loop, you know. You go from one device to the next, 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 until you've hit them all. And the print shows you there's a circle for a smoke detector or a heat detector. It'll have an S or an H or even a D. And now, when you're doing those the duct detectors, those motors are going to be run by VFDs. And you're going to need to get your pipe over to those VFDs, and you're going to need to mount a box for every VFD that's there, because you're going to need to flex into every VFD that's there. Usually they run liquid tight, I believe, but I don't know. It depends on what you're doing. So, but you're going to need to run that down to the boxes that are below the VFDs. And then you're going to need to be able to run your wires up. You're going to go in and out of the module that it's connected to. And then that module is going to have a wire that connects to normally closed, I believe. You have to read the directions. Like I say, always read the directions. But anyways, you connect that. There's a jumper in the bottom of the VFD. You take that off, and then you connect the module to the VFD. And it's like a CR something or other. It's a control relay. It just makes or breaks contact if there's power applied to it or not. So normally open, normally closed, the state that it's in when it's not energized, the normal state. So if in the normal state, you would want it to be normally closed, so that it would keep the thing running, just like a jumper. But you break that circuit and the thing shuts down, so the fire alarm system can shut down the air conditioners. And they connect to the tamp and flow. There's modules for those too. And it tells it if one of the fire sprinkler pipe or one of the fire sprinklers got set off and water starts running, then the fire alarm will know, because those switches inside there tell the fire alarm panel, hey, there's water flowing through my fire sprinkler pipes, and that's not normal. So, we connect stuff to that on normally open, so if anything ever happens, then it sends out a circuit saying, hey, there's a problem here. So, anyways, yeah, that's pretty much your fire alarm system for you. If you were to run a Class B fire alarm system, you wouldn't need to be making that loop. You would just need to run a series in and out, in and out, in and out through all your devices till the end of the line, and then you put a resistor. You connect the end of the line with a resistor, and that's what ends the line. So the benefit of the Class A system is that if a pipe ever got cut, and that's the reason for that 6 feet of separation and stuff like that, because you only want somebody to accidentally cut through one pipe before that fire alarm goes off. If they end up cutting through 2 pipes, then you've lost connection with maybe even possibly a whole section of your system. You never know. 6 feet of separation. Somebody makes a mistake, cuts a pipe they shouldn't be cutting. 6 feet of separation. One pipe. You know where the problem is, because the fire alarm system can address all the devices still, because it can address them from either end, by either panel they're connected to. So it'll actually be able to tell you where the break is, and you can go over there and you can fix it. Run a new wire, connect it back together. And with fire alarm, you can never splice wires in a box. You always have to pull that stuff straight through to the next device. No makeup. Only like in the horns, basically. When you go into a horn, you have to have a makeup in there. But with your smokes, you have to have a ground in there. So your horns have to have a ground. But your smokes and your heat detectors and your duct detectors, those just get data. It's just a black and a red. And directions show you how to hook it up, so do it that way and you'll be all good. I don't really know how to really make up the panel. I've seen inside them. I know that all the horns mount to the right side of the circuit board, where all those contacts are, and the smokes, I believe, mounted to the top connections on the port. I can't remember. I'll have to poke my head inside one of them things one of these days, and I'll make a video on that too. So I'll show you how that all gets hooked up. And you need to run a circuit to that fire alarm panel so that it powers the panel and keeps the whole thing running. But that's pretty much it. It's pretty easy. If you have to pipe it, it's hard. If you can free air it, that's easier. If you can free air it, keep it above the grid. People have to work underneath the grid every now and again, or above the grid every now and again. And it really sucks when those wires are just like right in the way all the time. So keep your wires high. I don't care if you have to get taller ladders or whatever you have to do. Keep your stuff high. It really sucks when people have to work like that. Anyways, this is BMO signing off. Later.